Hi everyone, my name is Nihar. This is my presentation on the Iterator design pattern for CIS 566. So what is the intent behind the Iterator design pattern? The intent is to provide a way to access the elements of an aggregate object without exposing its underlying representation. So if you have an array or a list, you want to be able to access the list without accessing the representation, the underlying properties. What is the motivation behind the Iterator design pattern? Let's say an aggregate object, such as a list, should give you a way to access its elements without exposing its internal structure. So you might want to traverse the list in many different ways. However, you don't want to bloat the list interface with operations for different kinds of traversals, even if you can anticipate which traversal you might need. In addition, you might also want to be able to have multiple traversals occurring at the same time. The Iterator design pattern lets you accomplish this by taking the responsibility for the access and traversal out of the list object and putting it into an iterator object. The iterator object keeps track of the current items being traversed, the next items to be traversed, and the current state of iteration. As you can see here, you have a list object here. The traversal for this list object is put into a list iterator object. It has a first, next, is done, and current methods that keeps track of the iteration on the list. So when should you use the iterator design pattern? You want to use the iterator pattern when your collection has a complex data structure under the hood, but you want to hide its complexity from its clients. This can be either for convenience or also for security reasons. You want to use this pattern to reduce the duplication of the traversal code across your application. In addition, you want to use this iterator pattern when you want your code to be able to traverse different data structures or when types of these structures are unknown beforehand. For example, if you don't know which structure you're going to iterate through, you might want to use this iterator pattern to be able to generalize the iteration, the traversal of the object. This is the structure of the iterator design pattern. As you can see, you have an iterator that has methods for first, next, is done, and current item. You also have an aggregate that creates the iterator, and the client references the aggregate and the iterator. You have the concrete aggregate that implements the aggregate interface, and you have the concrete iterator that implements the iterator interface. So these here are the participants in the iterator design pattern. First, you have the iterator, which defines an interface for accessing and traversing the elements. You have the concrete iterator, which implements the iterator interface. It also keeps track of the current position in the traversal of the aggregate. The aggregate defines an interface for creating an iterator object. The concrete aggregate implements the iterator creation object to return an instance of the proper concrete iterator. So, what did we just talk about here? The iterator defines an interface for accessing and traversing elements. If we go back here, we have the iterator interface right here. We have multiple methods. We can add a lot of them after this if we want to, depending on our traversal. You can have first, next, is done. We can also have a last element if we want to, and current item, and it keeps track of the current iteration. The concrete iterator implements this interface. If we go back here, the aggregate defines an interface for creating an iterator object right here, and then the concrete aggregate implements this aggregate. The concrete iterator and the concrete aggregate communicate back and forth to keep track of the instance of the proper concrete iterator. So what are some of the consequences, some of the results from the iterator design pattern? One of the consequences or results is that it supports variations in the traversal of an aggregate. Iterators make it easy to change the traversal algorithm. In order to do this, you just need to replace the iterator instance with a different one. You can also define iterator subclasses to support new traversals. Another result is that iterators simplify the aggregate interface. The iterator traversal. Another result is that more than one traversal can be pending on the aggregate. An iterator keeps track of its own traversal state. As a result, you can have more than one traversal in progress at once. This can be really helpful when you have a program that is multi-threaded. You want to be able to loop through or traverse through an object with multiple threads executing at once. So what are some known uses for this iterator design pattern? The iterator design pattern is most used in object-oriented applications. For example, some of the object-oriented languages are defined here, such as C#. In C#, the IEnumerator interface implements the iterator design pattern. The IEnumerator generalizes a bunch of arrays or lists into an IEnumerator, and when you cast an array or a list as IEnumerator, it generalizes the traversal into this one interface. In C#, the iterator design pattern is included in the standard template library. In Java, the iterator is implemented in the java.util.iterator interface. Now we'll go into the demo of the iterator design pattern. So we have a scenario here where you have a list of contacts in an address book. The program requires a user input that allows you to display the contacts in either ascending order or descending order. The address book is traversed without exposing the underlying representation of the object. And we'll talk about this in further detail now. This is the class diagram of the demo. You have the address book, you have the contact, you have the contact info. The contact info is just a model that contains properties for the contact. You have an aggregate right here. You have the concrete iterator. You have the ascending and descending as the concrete iterator. You have the abstract iterator. So as we mentioned here, so abstract iterator is the same thing as just the iterator, the concrete iterator, the aggregate, and the concrete aggregate. So we can define them here. These two, ascending and descending, are the concrete iterator. This is the iterator interface. This is the concrete abstract iterator. The concrete aggregate. Address book is the concrete aggregate, and this is just the aggregate. As I had mentioned before, the I-abstract address book is the aggregate. It defines an interface for creating an iterator object. It defines the ascending iterator and the descending iterator. You also have the concrete iterators. Here you can see the code for the ascending iterator and the descending iterator. In the ascending iterator, you can see how you can traverse, you can retrieve the first contact, the next contact, the current contact, and whether the list has been traversed, the address book has been traversed. This is the same in the descending iterator. It implements the descending iterator interface, and it keeps track of the current position in the traversal of the aggregate. This here is the iterator interface. It defines an interface for accessing and traversing the elements. The concrete iterator, as we had mentioned here before, implements this iterator interface. You also have concrete aggregates. This implements the iterator creation object to return an instance of the proper concrete iterator. And then the contact class simply defines the methods and properties of a contact in an address book. As I had mentioned before, the contact info is an object that defines all the properties in a contact. It contains properties such as ID, first name, last name, phone number, and email. Now let's go to the demo. This is the program right here. As you can see in the address book, you have multiple contact information. The program allows you to choose whether you want to display this contact information either in ascending or descending order. Depending on the user input, if the user inputs 1, it will display in ascending order. If the user inputs 2, it will display in descending order. Let's test this out. So if we input 1, it will display in all the contacts in the address book in ascending order. As you can see, 1, 2, 3, 4, 5. It's in ascending order. If we want to display in descending order, you can input 2. And as you can see, the ID is 7. It's displaying the contacts in descending order. So this is the demo for the iterator design pattern. Thank you.